Welcome to the DIY Honda Garage channel. DTC P2097, which stands for Diagnostic Trouble Code, Post-Catalyst Fuel Trim System Too Rich, indicates an issue with the fuel trim after the catalytic converter in a 2011 to 2015 Honda Civic. Fuel trim is a critical aspect of the engine's fuel management system, and it is essential to maintain the correct air-fuel mixture for optimal engine performance and emissions control. In this case, a rich fuel trim suggests that the engine is receiving too much fuel or not enough air after combustion occurs in the catalytic converter. The fuel trim values are managed by the Engine Control Module, ECM, which interacts with various sensors, including the air-fuel, AF sensor, and the secondary heated oxygen sensor, HO2S. To effectively diagnose and correct the problem, it is crucial to start a thorough investigation of both the fuel system and relevant exhaust components. Error DTC P2097 indicates a rich fuel trim condition occurring after the catalytic converter in the exhaust system. The affected components primarily include the AF sensor, Sensor 1, and the secondary HO2S, Sensor 2. The AF sensor, often referred to as the oxygen sensor, plays a critical role in measuring the air-fuel mixture before it enters the engine, while the secondary HO2S monitors the efficiency of the catalytic converter post-combustion. These sensors relay information back to the ECM, which adjusts fuel delivery to optimize engine performance and emission levels. The AF sensor is typically located near the engine's exhaust manifold, whereas the secondary HO2S is positioned downstream in the exhaust system. Understanding the positions and roles of these components can help in effectively diagnosing DTC P2097. Several potential causes can trigger DTC P2097. Firstly, an exhaust leak between the AFAC sensor, Sensor 1, and secondary HO2S, Sensor 2, can expose the post-catalytic sensor to excess oxygen, altering its readings. Secondly, clogged or blocked exhaust components can restrict the flow of exhaust gases, creating an imbalance in the air-fuel ratio, leading to a rich condition. Thirdly, a malfunctioning AFAC sensor may provide inaccurate data to the ECM, resulting in incorrect fuel delivery. Additionally, issues with the secondary HO2S can affect the ECM's understanding of the catalyst's efficiency and also lead to miscalculations in the fuel trim. Lastly, problems within the fuel system, such as faulty fuel injectors, could contribute to excessive fuel delivery. Each of these possible causes must be systematically investigated to pinpoint the issue. Symptoms associated with DTC P2097 typically include poor engine performance, where the vehicle may feel sluggish or unresponsive due to improper fuel delivery. Additionally, increased emissions can be a notable sign, as a rich fuel condition often leads to higher output of pollutants. Another common symptom is the illumination of the check engine light, CEL, which alerts the driver to the underlying issue that requires attention. Moreover, rough idling may occur, characterized by irregular engine speed or excessive vibration when the vehicle is at rest. Collectively, these symptoms serve as indicators that further diagnostics and repairs are necessary to address the rich fuel trim condition indicated by DTC P2097. The first troubleshooting step for DTC P2097 involves verifying the problem through specific ignition and monitoring procedures. Begin by turning the ignition switch to the on position, which activates various electronic systems without starting the engine. Next, clear any stored diagnostic trouble codes using the Honda Diagnostic System, HDS. After clearing, start the engine and maintain an engine speed of 3,000 RPM, ensuring the engine runs without load until the radiator fan engages. This step is important because it helps in re-establishing baseline conditions that may affect the fuel trim readings. Once the fan activates, allow the engine to idle for accurate readings before proceeding to the next steps in the diagnostic process. During the second troubleshooting step for DTC P2097, a test drive of the vehicle is necessary to simulate real-world conditions. Begin by ensuring that the engine coolant temperature is above 158 degrees Fahrenheit or 70 degrees Celsius. This is vital as it signifies that the engine is operating properly and allows for accurate sensor readings. During the test drive, the transmission should be in fourth gear and the engine speed must be maintained at less than 4,000 RPM. Drive within the speed range of 15 to 75 miles per hour for at least 1 minute to gather sufficient data. After performing this test, monitor the onboard diagnostics (OBD) status with the HDS to see if DTC P2097 has occurred again. This step verifies if the fault condition remains consistent. The third troubleshooting step addresses whether the HDS indicates a failure for DTC P2097 during monitoring. If the HDS shows a failed status, it confirms that the problem is ongoing, warranting further diagnosis. At this stage, it is crucial to check for poor connections or loose terminals, specifically at the AF sensor, Sensor 1, secondary HO2S, Sensor 2, and the Engine Control Module, ECM. Often, electrical faults can mimic sensor issues. Additionally, if freeze data or an onboard snapshot is recorded, reproduce the failure conditions to gather more insight into the problem's nature. Alternatively, if the HDS indicates the diagnostic has passed, it suggests so that the issue may be intermittent and indicates that the system is operating correctly at that moment. In the fourth troubleshooting step for DTC P2097, you need to conduct a thorough examination of the exhaust system. Begin by checking for any leaks that might occur between the AF sensor, Sensor 1, and secondary HO2S, Sensor 2, as such leaks can significantly affect the readings of post-catalytic sensors. Next, inspect for any clogging or blockages throughout the exhaust system. Clogs could be due to higher levels of carbon buildup or damage from external debris, both of which can restrict the flow of exhaust gases, thereby impacting fuel trim. If any leakage or blockage is identified, repairs or replacement of the affected exhaust component is mandatory before continuing further diagnostics on DTC P2097. This step is essential to ensure the exhaust system is functioning properly, as it plays a critical role in the overall performance and emissions of the vehicle. The fifth troubleshooting step involves a substitution check of the AF sensor, Sensor 1, to confirm its functionality. Begin by disconnecting the faulty AF sensor and substituting it with a known good sensor. This substitution is crucial to rule out the possibility of a faulty sensor causing the rich fuel trim condition. After replacing the sensor, ensure that all electrical connectors are securely reattached. Then turn the ignition switch to the on position again to activate the systems without starting the engine. Following this, it's necessary to reset the Engine Control Module, ECM, using the HDS. This resetting clears any erroneous codes or memory that could affect the fuel trim calculations, establishing a clean slate for accurate sensor evaluations moving forward. In the sixth troubleshooting step for DTC P2097, you'll proceed to perform the ECM idle learn procedure. Start the engine and maintain an engine speed of 3,000 RPM, as previously done, to familiarize the ECM with the new sensor's readings and ensure that the system is recalibrated. Keeping the RPM steady allows the ECM to to adjust fuel parameters according to the new operational baseline. As the engine runs, observe its response to maintain stability, confirming that the new sensor is being recognized properly. After the initial stabilization period, with the RPM held at 3,000, let the engine idle and gather data for further evaluation. Performing the ECM idle learn is essential to allow the system to optimize its fuel trim calculations based on the new AF sensor input. During the 7th troubleshooting step for DTC P2097, you will conduct another test drive under specified conditions to assess the effectiveness of previous steps. Ensure the engine coolant temperature is again above 158 degrees Fahrenheit, 70 degrees Celsius, and keep the transmission in 4th gear. Similar to before, maintain engine speeds under 4,000 RPM and drive within the 15 to 75 miles per hour range for at least 1 minute. This drive aims to closely simulate the operational conditions that would have triggered P2097. Post-drive, monitor the OBD status using the HDS to determine whether DTC P2097 has returned. Analysis of this data will help decide the success of the repairs performed and guide any further steps necessary, such as determining whether the original A-factor sensor should be replaced based on the monitoring results. In the final troubleshooting step for DTC P2097, examine the readings from the HDS once more. If the system indicates a passed status after performing the aforementioned checks and tests, this suggests that the issue is resolved. In this situation, you should proceed to replace the original AF sensor, Sensor 1, which was substituted for testing. If the HDS still indicates a failed status, this may signify the need to replace the secondary HO2S, Sensor 2, as it too could have an impact on the fuel trim readings post-catalyst. If either sensor replacement is necessary, underlying conditions should be monitored closely to ensure they alleviate the issue at hand. It's essential to keep comprehensive records of all actions taken and diagnostics performed during this process for future reference or warranty purposes. After performing all necessary repairs related to DTC P2097, it is crucial to conduct a final verification of the repair work. This step involves closely monitoring the system over a specified period. Pay particular attention to the fuel trim readings and the OBD status to ensure the vehicle continues to operate without reoccurrence of the Diagnostic Trouble Code. Check for consistency in the sensor readings. Stable data confirms that the repairs have been successful. Additionally, it's advisable to keep an eye out for any new codes that may arise, as they could indicate underlying issues that were not initially addressed. Regular monitoring allows for early detection of potential issues, ensuring the long-term reliability of the repair work completed. To prevent the recurrence of DTC P2097, it is advisable to establish a preventive maintenance routine focused on key components. One of the primary areas of focus should be regular checks of the exhaust system for any signs of leaks, clogging, or damage. This includes ensuring that sensors such as the AF sensor, Sensor 1, and secondary HO2S, Sensor 2, are functioning properly. Keeping these sensors clean from carbon buildup and debris can significantly enhance their performance and lifespan. Moreover, ongoing monitoring of the fuel system for any potential issues is critical. Regular maintenance and timely inspections can help in catching issues early, ultimately contributing to the overall reliability and efficiency of the Honda Civic. In conclusion, DTC P2097 indicates a critical issue related to rich fuel trim in the Honda Civic's fuel management system. Understanding this diagnostic trouble code is essential for accurate repair and maintenance. performing thorough diagnostics enabling repairs of both the AF sensor, sensor 1, and secondary HO2S, sensor 2, is paramount to restoring the vehicle's optimal performance. Changes based on proper assessments, including exhaust checks and potential substitutions of faulty sensors, are necessary for effective troubleshooting. Furthermore, implementing a regimen of regular maintenance and ongoing monitoring can proactively address any arising issues, ensuring a continuously smooth operation. Being proactive about these aspects will greatly enhance the vehicle's performance and reduce the probability of encountering DTC P2097 again. Please like and subscribe to the channel. See you next time.